In this final group of videos, we're going to talk about more of typesetting mathematics. And you'll see some of the finer points that you have to consider because mathematical typesetting is an art. So let's go to my desktop and the website, which is here. As I said, it's a work of art. Now, LaTeX knows a lot of the basics, and indeed more about the basics than most authors know. But you still have to fiddle around to get the best results. So one of the things to learn is what sort of thing is best. So pick up on that as we go along. And from time to time, we will look at an example little document which has got lots of maths typeset into it that I will discuss. So here's the source, which you might show, and here is some of the output. And as you can see, we're going to look at theorems, accents, delimiters, spacings, functions, command definitions, arrays, and equation arrays. So let's put that away for the moment. Now, we've already talked about some of the basics of maths, how to include maths inline or to display maths with some of the basic environments, and whether you use the equation environment if you want to number a mathematical display, how to put sub and superscripts, frac command to typeset fractions, and that there's many mathematical symbols such as the entire Greek alphabet. Right, and that's under that link there should you need it. So we're going to show quite a lot of examples here. This page typesets some of the mathematical examples in the page using MathJax, and it's a okay-ish rough typesetting package for the web. That's why I'll show you the real deal in the LaTeX source. Okay, now as I've mentioned before, the very first thing to do is always include the AMS packages. And the basic one, just get into the habit of it, put it in your style file. The basic one is use the package AMS Math. But there's a few others you may like to include as standard. One of them would be AMS Sim, which gives you a suite of symbols from the American Math Society. See what sort of symbols are available. You can download this list, or this summary by Emery is also quite good because it gives you the basic LaTeX symbols as well. I've got that here. Let me show it to you. Let's whiz it up. My margin's a bit thin for some reason. There we go. Now he's typeset it using Beamer, but I won't hold that against him. Not much anyway. Okay, so he's got a list of LaTeX and AMS LaTeX symbols. It's indexed down the side here, and then there's a few extras at the bottom. So common LaTeX symbols in maths are all these sort of things. As I promised, the entire Greek alphabet, whole suite of binary operators and inequalities to choose from. There's triangles, there's arrows, operators, functions, miscellaneous. In fact, there's several inequalities. That's inequalities 1 and 2, right? And he makes no distinction between the standard LaTeX and the symbols in AMS LaTeX, package AMS Sim. These are all in there. Yeah. And then there's triangles and harpoons, etc., etc., etc. With various alphabets, and I'll comment a little bit about these. Be careful about them. various brackets, which we'll talk about. There's various dots, which we'll talk about, and various other things. So it is handy to have that around. Now, one of the things, fonts. Don't get carried away. Do remember your reader, because again, you typeset the document, you know what you mean. The question is, do you read it? Now, one of the things I definitely say do not do, and that is you do not use the Math SCR font. It is quite common, and frankly, I can't tell half the symbols apart. You know, I, J, P, T, S, I think they're almost the same. And if you see them sort of on their own in a body text, I don't know which one you mean. It's just awful. For curvaceous characters, just stick with the basic, clean, simple math count. People, readers will thank you. Actually, they won't, because they won't know. Okay, so they're the basic symbols. As I've mentioned, there are a lot of others. So the comprehensive LaTeX symbol list has got a list of 14,283. That's more than you would ever dream of in your nightmares. Now, one thing that is handy that you may want to use is the Techify web server, which looks like this. There is a desktop version as well. And basically, you draw the symbol that you want, and this service will make suggestions. So let's draw a less than, approximately less than symbol. Suppose I want that. Okay, it says, well, I can't find a particularly good match, but this one here seems good. Right, so if you say, yeah, that's right, that'll do. The Techify will tell you which package you need and what command you need. Isn't that great? And then there's variations on the theme down here as well. So there's these ones in AMS Sim, and yeah, there's others. That will do. Roar away. Now, the other thing, we've also mentioned theorems. AMS provides theorem environment, which extends what's in the normal LaTeX. So if you need theorems, definitions, corollaries, etc., use package AMS theorem. Remember to put cleverf after you've loaded the package and before you've defined theorems. Thereafter, in the body of your document, you can include a theorem, corollary, whatever, between begin theorem, end theorem, or whatever. And there's begin proof, end proof. In these definitions, I don't know that I mentioned it, but let me mention it now. The square bracket theorem here is good. What it says is all of these entities use the same counter. So you'll have the same numbering stream running through your document. You may think that's a bit weird. I'm sure you want theorem 1, and the first corollary should be corollary 1, the first definition should be definition 1, and first theorem, theorem 1. But actually that does not help your reader. You know, when you're referring to these things in the text, you number them so that your reader can find them again in cross-referencing. Now, how's the reader to know where corollary 1 is? Could be anywhere. But if you number definitions, theorem, corollaries, lemmas, all with the same numbering stream, then they know that corollary 3 will come after theorem 2 and before definition 4. So as your reader is flicking through the paper or whatever, because there's only one strand of those numbers, it will be easier for your reader. So, as I said implicitly, label and cross-reference these as usual. The environments you create with new theorem, so theorem corollary, lemma, etc., you can add an optional argument that provides a name to it. So if you've got a definition of right angle triangle, you may want to put the name right angle triangles up front in the definition, and it'll get typeset as definition 3, whatever it is, and then in parentheses right angle triangles, and then the body of whatever you do. So you can see that sort of thing in, in this source. Now, one of the things about this source I might as well mention, just for a bit of fun, is occasionally you do want a big font, a document with a big font, especially for stuff which you display on a board. Say seminar announcement, poster, a sign saying tea room, or a sign saying colloquium here today. You know, you want a big font. You can do that in LaTeX using the ext articles document class, and it gives you font sizes 14 point, 17 point, 20 point. To illustrate 20 point, I've typeset this document on an A4 paper in 20 point. It's quite big. Okay, Theorems et al. Yeah, here's an example. Typesetting. You can see definition 1 down here has got that optional argument, parentheses right angle triangle, and then the definition, lemma, theorem, they're all typeset in italics just to stand out a little bit from the body text, the rest of it. Okay. Yeah. Accents. Often in mathematics, we need a symbol for a quantity that's got a close relationship to another quantity that we've already got a symbol for, but is nonetheless distinct, such as a Fourier transform. Fourier transform f, then we want the Fourier transform somehow to be easily related back to f by a reader. And the way we do that is by accents. And the same for many quantity symbols that are closely related. So use a mathematical accent. What sort of accents have we got? Well, these are the basic ones. Backslash bar to put a bar over a symbol, tilde to put a tilde, hat to put a little hat over a symbol, dot to put a single dot for usually time derivatives, but not necessarily, could be other purposes. Double dots to put a double dot, second time derivative. And vec we've seen, puts a little arrow over the top. That's its default. You can stack accents on top of each other. You just have to put the outermost accent applying to a braced inner accented symbol. So yeah, here's some examples, but it's better in LaTeX. Right, so here we are. So here we've got f tilde, because it's the Fourier transform of function f, or we might be doing rotational motion. We've got vector omega, dbt of it, that's the dot, is vector r cross vector I. And where's the source for all that? It's just here. So the last one is pretty easy, right? With vec for the vec and dot with braces for the overdot. Backslash tilde f. That's the tilde. Okay, so that's a start on more mathematics. Take a break before we go on to the next topic, which is the limiters.